Hello students, welcome back. In this video, I'm going to solve the rest of the questions from JEE Main 2026 session 1 question paper. There are four statements given about the biomolecules. We need to choose the right statements from the given options. Let's analyze the statement one by one. Activation energy for enzyme catalyzed hydrolysis of sucrose is lower than that of the acid catalyzed hydrolysis. This is a true statement. There are different ways of asking this question, and this is most frequently asked concept. So that's why I'm going to explain this in detail. So let's see, what do you mean by hydrolysis of sucrose? So students, remember, when sucrose is hydrolyzed, it's going to form two monosaccharides, that is glucose and fructose. There are two ways of doing it. One is in presence of acid catalyst, right? In presence of acid catalyst. There is one more way of doing it by using a biological catalyst, that is nothing but the enzyme sucrase. Sucrase also does the same job of hydrolyzing sucrose to glucose and fructose, but it takes a different pathway. How so? Let's look at the activation energy graph. So on the x-axis, I'm going to take how the reaction is progressing, how the reaction will progress. That is nothing but it will convert to reactant to product. On the y-axis, it's always the energy. It shows increase in the energy. Now, when sucrose is undergoing hydrolysis, it will reach a transition state and then converts to the product, right? And then what happens when you do it in presence of an enzyme sucrase? The reactant and products are same, but the pathway is different and it's taking a transition state with the lower energy. That means what? If you want to compare the energy of these two, then you can consider this as activation energy, and this is activation energy 1. So in the absence of the enzyme, we call this as activation energy. And when you compare the energies here, it's quite obvious that the activation energy 1 will be less as compared to activation energy 2 because of the presence of the enzyme, which is very specific to the reaction, and it takes an alternative path to form the products wherein the energy is way less. Therefore, the given statement is correct. And where do we have A option? In 1, 2, 3, but not 4. So let's eliminate that. Now let's check for B. During denaturation, secondary and tertiary structure of proteins are destroyed, but primary structure remains intact. So whenever we have proteins, the amino acids, the sequence of amino acids are going to form the primary structure. When we do denaturation in presence of either acid or a base or by heating, this will not going to change. It's going to remain intact, right? That's why this is also a true statement. Now, where do we have B? We have in 2 and 3. So eliminate 1, right? Now, look at these two options. There is no C here. So if you want, you can directly ignore this and move on to the fourth statement. However, I'm going to explain whether or how this is a wrong statement. Nucleotides are joined together by glycosidic linkage between C1 and C4 carbon of the pentose sugar. This is a wrong statement. So why so? Because the nucleotides are made up of phosphate and a sugar, a pentose sugar, and it will be attached to a nitrogenous base. Right, we have 4 different nitrogenous base. Similarly, there will be one more nucleotide which is also made up of phosphate sugar and a nitrogenous base, like this. Now, what is the link between these two units? The link is always between the phosphate and the sugar, like this. Similarly, this sugar is going to interact with the phosphate, and this linkage is called as the phosphodiester linkage. So remember, nucleotides are joined together by a phosphodiester bond to form the nucleic acid. So this is a wrong statement. Now let's check the fourth one. Quaternary structure of protein represents overall folding of the polypeptide chain. This is a wrong statement. Why so? The quaternary structure refers to the spatial arrangement and interaction of multiple polypeptide chains into a single functional protein complex. But here it says that it's just the overall folding of the polypeptide chain, which is not correct. In fact, tertiary structure represents the overall three-dimensional folding of a single polypeptide chain. So that's why this is also a wrong statement, right? So what are the right statements we have? A and B. Therefore, the right option is option 3. In the next question, we have to arrange the given different nucleophiles in the order of their reactivity towards the bromomethane. So that means what? The nucleophile attacks the electrophilic carbon and bromine leaves the molecule to form the product. So whichever is the better nucleophile, the order of reactivity for that reaction will be higher. So how do you know the order of nucleophilicity? When the electrons are localized on one atom and it easily donates the electrons to the electrophilic carbon, then we consider it as a better nucleophile. See, the other nucleophiles, like say for example, phenoxide, which is obtained from the phenol. The lone pair is not just on the oxygen, it can undergo resonance. So it is being stabilized by the benzene ring. So due to this, it's not a better nucleophile as compared to hydroxide. Even with respect to acetate. Acetate is from the acetic acid. Here also the electrons are undergoing resonance. So the electrons are delocalized. So when the electrons are delocalized, this is a stable molecule. That means it will not attack the electrophilic carbon. So it's not as good as a hydroxide. Same with the perchlorate. So what is the structure of perchlorate? If you don't know the structures of these molecules and if you are not aware of the resonance, then you can't answer this question. So remember, you're going to compare the structures, their resonance, and then the nucleophilicity. All these are linked together. Here you see in perchlorate, there are 3 oxygen right here, which can stabilize the negative charge further. So that's why this is going to be the least nucleophile. So where do we have this as a least nucleophile? In 3 options. However, there is only one option wherein the oxygen of the hydroxide is localizing the electrons and acting as a good nucleophile. There is only one such option. Therefore, the right option is option 4. So students, remember one more thing. Whenever the question is a little bit difficult or moderate to difficult, then the options are going to be somewhat easier, like in this case, right? So don't ever skip reading the options. Whenever you read the question, make sure that you are reading all the options as well, because sometimes the options will also give you the right answer, like in this case. In this question, we are going to correlate the covalent bond length with respect to the bond orders for different bonds given here. The bonds given are carbon hydrogen single bond, so carbon oxygen single bond, carbon oxygen double bond, and carbon nitrogen triple bond. So you might have come across all this kind of bonds in organic molecules. So which one will have the highest bond length? So that is the question here. So as the bond order increases, that means what? When two atoms have 3 bond order, there are 3 bonds between them, the bond length will be less. So as the bond order increases, the bond length decreases. Therefore, the D will have less as compared to C as compared to B. Okay. However, not just the bond order, we need to look at the size of the atoms also. Oxygen and nitrogen have comparative atomic size. That's why I just simply considered the bond order and bond length, right? So higher the bond order, less the bond length. So I used that concept. But whenever you have small atoms like hydrogen, what happens to the bond length? The bond length decreases. So the carbon hydrogen bond length will be even less as compared to carbon nitrogen. So that's why it goes in the end. And where do we have it? We have it ADCB in option 2. Therefore, the right option is 2. Given below are 4 compounds: N-propyl chloride, isopropyl chloride, secondary butyl chloride, and then neopentyl chloride. All common names are given. So how you easily you will convert these common names to structures? You will get the answer that quickly. Now, what is the percentage of carbon in the compound which exhibit optical isomerism? So the question is in two parts. One is to know which molecule is optically active. The second one is, once you know which is optically active, then you can find out the percentage of carbon from that particular compound. Is this optically active? No, because there is no chiral carbon. Is this optically active? No, because the carbon is attached to methyl. Is this optically active? Yes, because the carbon is attached to methyl, ethyl, chlorine, and hydrogen. So this is also not optically active. So our compound which is optically active is secondary butyl chloride. So let's find out the number of carbons present here. So there are 4 carbons. So what is the mass of the carbons present in it? So 48. What is the overall molecular mass of N-butyl chloride? The overall molecular mass is 92.5. Right? How do we know that? There are 4 carbons, so it will be 48. And how many hydrogen will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. And what is the mass of chlorine? 35.5. Simplify this, you are going to get 92.5. Now, this is the mass. Now, what is the percentage of carbon? The percentage of carbon is equal to the overall mass, that is 92.5, and the mass of carbon, that is 4 carbons here. So multiplied by 100. So when you solve for this, you're going to get 51.8. So round it off, you will get 52. So 52%, where is it? In option 1. Therefore, the right option is 1. Let's see the last question from this paper. So there are two molecules X and Y, and they have given statements 1 and 2 respectively. And you have to analyze whether both the statements are true or false. So the compound X is soluble in sodium bicarbonate and it has 2 chiral carbons. Is this a true statement? Yes, it is true. Why so? Because of the presence of the carboxylic acid, it is soluble in sodium bicarbonate. And let's check for the chiral carbons. So benzene cannot have the chiral carbon here, so you can ignore that. Same with this carbonyl carbon because it's sp2 hybridized, so you can ignore this. But look at this carbon. This is attached to carbonyl, a tertiary carbon, a secondary carbon, and in turn it is attached to hydrogen. So all 4 different groups. Therefore, this is chiral carbon, right? And now let's check for the other chiral carbon. It's attached to tertiary, then CH2, COH, and of course there is a hydrogen. Yes, there is one more chiral carbon here also, right? There are 2 chiral carbons in the molecule. What about here? CH2, CH2, CH2. Not possible. So the first statement is a true statement. Let's analyze statement 2. Compound Y, shown below, has 2 carbons with sp3 hybridization, 1 carbon with sp2, and 1 carbon with sp hybridization. So it's very easy to identify the hybridization depending on the number of sigma bonds. So remember, if there are 4 sigma bonds around the atom, it will be sp3. If there are 3 sigma bonds, then it is sp2. If there are 2 sigma bonds, then it is sp hybridized carbon. Say, let's analyze here. There is a carbon here and then it is attached to 3 hydrogen atoms. So 1, 2, 3, 4. There are 4 sigma bond means this carbon, right? Methyl is sp3. Methyl will be sp3 all the time, right? It's quite obvious. Let's look at this carbon. 1, 2, 3, 4. All of them are sigma. So this is also sp3. Now, the first part of the statement, there are 2 carbons which are sp3. That is correct. There are 2 carbons which are sp3. Now, let's analyze this particular carbon. 1, 2, 3. Because when you have double bond, one will be sigma, the other one will be pi. So ignore the pi. 1, 2, 3. 3 sigma bonds means this is sp2 hybridized. So there is one sp2 hybridized carbon. So do we have one sp2? Yes, right? Let's check this carbon. There is only one carbon left now. So you see it's linear. When it will be linear? When it is sp hybridized. So this is one way of doing it. The other way is, so there is 1 pi here, 1 pi, 1 sigma, like this. So how many sigma bonds are there? 2 sigma bonds. So 2 sigma bonds means sp hybridized. So this carbon is sp hybridized. So there is one carbon which is sp hybridized. Do we have that in the statement? So there is one carbon which is sp. So this is also true statement. Therefore, both the statements are true. And where do we have it? We have it in option 3. Both statement 1 and 2 are true. Thank you for watching this video. In the next video, I'm going to solve some more IIT JEE questions.